In this video, we're going to look at the two theorems, the remainder theorem and the factor theorem. So the remainder theorem is basically giving us a choice. If they ever ask you to find the remainder when you divide by a certain factor, for example, if they say divide the polynomial by x minus 3, instead of using synthetic division and looking at that last number you get from your answer, you can also just plug the number from the factor directly in for x. So replace all the x's in the polynomial with that same value that you would have used synthetic division by, and you'll get the remainder that way as well. So it's basically just giving you two different ways to find the remainder of a function. Either replace the x's or use synthetic division and look at the last number in your answer line. So here's an example, and I'll show you how you get the same answer either way using either technique, and that way you guys will have the option of picking whatever looks like it will be easiest or fastest for you. So this one has asked us to divide x cubed minus 3x plus 4 by the factor x plus 2. So if I was using the synthetic division method, I would write -2 in a box, and then my coefficients would be 1. Don't forget, since I'm skipping x squared, it went from x cubed to x to the first, I have to fill in a missing 0 here, and then -3, and +4. So for my synthetic division, the first number comes down, multiply by the box, add the column, multiply the box, add the column, multiply the box, and add the column. So in this case, I have found that the remainder is 2. And that was fairly simple. It was fairly straightforward, so it's not a bad way to find the remainder. However, the alternative method that I'm showing you guys now is you can instead take that solution of -2 and replace the x's with that value. So I could instead say, what is -2 cubed minus 3 times -2 plus 4? Well, -2 to the third power is -8. -3 times -2 is +6. And then this last part just stays as a +4. 6 plus 4 is 10. If you subtract 8 from that, you get 2. So either way, you get the same remainder. This will come in handy once we add some other theorems that will be dependent on getting a remainder of 0. That way, sometimes you can just look at the polynomial and see if plugging in the number looks like it will equal 0 or not. And then if it does look like it will equal 0, then you can go ahead and do the synthetic division to get the other part of our answer. But for right now, all I'm showing you is that you have the choice to find the remainder. You can either use synthetic division and look at the last number, or you can replace all the x values with the solution from the factor and see what you get when you compute. So here's the second important theorem that I was referring to earlier. If you divide or use the remainder theorem to get 0 for your answer, then basically what you've just found is that whatever you were dividing by is a factor of the polynomial, which means you could factor the polynomial down and x minus k would be one of your binomials in parentheses. It's one of those pieces that you can use to multiply by something else to go back to the original polynomial. So the translation here is if you get 0 when you either plug the number k into the function, or if you use synthetic division and look at the last number, then x minus k is one of the factors of the polynomial. This is going to be very handy when you are asked to factor bigger polynomials. We have techniques for things like difference of squares, trinomials, and even factoring by grouping for 4 terms. But when you have a longer polynomial, this is going to be an important piece of us figuring out how to factor it down and break it into smaller pieces. So one very popular question relating to the factor theorem is them giving you a factor and saying, is this a factor of some bigger polynomial? So this way we can test it in a sense. So again, the testing process, you can either do this using synthetic division or by plugging the number in. So if you use synthetic division, my solution would be 3. And then my coefficients are 1, -1, -1, and -15. Again, I didn't have any missing zeros because I have the third power, second power, first power, 0 power. So when I solve this synthetic division, the first number comes down, multiply by the box, add the numbers together, multiply, add, multiply, and add. So since this one came out to a remainder of 0 down here, that means that this is a factor. So for the question, is x minus 3 a factor, you would say yes. Now what this really helps us do is this lets us take this bigger polynomial and break it down as x minus 3. That's what we tested. And then if you multiply it by what's left here, the x squared plus 2x plus 5, that means if you distribute these two things out, you're going to come back to the original polynomial. So we've essentially factored this big ugly expression into two smaller parts, and then we could continue factoring the smaller parts that are left using quadratic formula or one of our other factoring techniques. But the way this question is worded, all they wanted us to say was that yes, x minus 3 is a factor. It will be important that we can break this down in the next upcoming sections. This question is very similar. It still says determine whether x plus 2 is a factor of this expression. Now, last time I did it using synthetic division, but remember part of what I'm saying to you is that you have a choice. The other thing you could do is instead of synthetic division, you could just plug the number into the x values. So in this case, my solution would be -2. So instead of using synthetic division again, I'm going to show you replacing the x's with -2s and evaluating it that way. You will get the same answer either way, so it's up to you which method you prefer. And personally, I think it kind of varies from question to question. Sometimes I use one method, sometimes I use another. It depends on how easily I think I can compute the number just by plugging it in. So in this case, -2 cubed is -8. -2 squared is 4, times 2 is +8. -5 times -2 is +10. And then I have this extra -6 at the end. So in this case, the -8 and the 8 would cancel. 10 minus 6 is 4. So my answer here is that this is not a factor. So is x plus 2 a factor of this? No. That means I could not break this down as x plus 2 times some other polynomial like x squared plus 3x minus 5, whatever it would be. So that means this one cannot be broken down using x plus 2. It would not be one of the factors of this original polynomial. So that's all for the notes. Again, just make sure you understand what it means when you have remainder 0. That means that it is the number that you were testing is a factor of the original polynomial. And don't forget that you have the choice. Pick for yourself whether you would like to use synthetic division to test these, or if you would like to just replace the x values and plug it in.